A bond bushing or grounding Locknut is required when landing a 3/4 flex connector into a disconnect using concentric knockouts for a heat pump that requires number 6 aluminum and number 10 ground. NEC section 250.124F requires a bonding jumper or grounding bushing to ensure electrical continuity between the enclosure and the grounded conductor, which is the neutral of the circuit. NEC section 110.26B requires that flexible metal conduit or metal-clad cable be terminated in a box, cabinet, or conduit body that has a grounding connection. When using concentric knockouts, the sharp edges of the knockout can cut into the insulation of the ground wire, creating a potential hazard. The bond bushing or grounding Locknut provides a secure connection between the equipment grounding conductor and the enclosure, preventing any potential loose connections or current leakage. The bonding bushing or grounding Locknut should be installed on the neutral side of the disconnect because the neutral conductor is the grounded conductor in a typical electrical system. Ensuring proper grounding and bonding is crucial for electrical safety and code compliance. Firstly, understand the purpose of grounding. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers or fuses to quickly trip and energize the circuit, thus preventing electrical shock hazards and minimizing equipment damage. Secondly, consider the role of bonding. Bonding connects non-current carrying metal parts of an electrical system to create an electrically conductive path. This path ensures that all metal parts are at the same electrical potential, reducing the risk of voltage differences that could cause electric shock. Thirdly, concentric knockouts present a specific challenge. Concentric knockouts are designed to accommodate different conduit sizes, but they can leave sharp edges that can damage wire insulation, especially the grounding conductor. This damage can compromise the integrity of the grounding system. Fourthly, a bond bushing or grounding Locknut provides a solution. These fittings create a secure and reliable connection between the metal conduit or connector and the metal enclosure, ensuring electrical continuity. The bond bushing typically has a sharp edge or teeth that bite into the metal enclosure, while a grounding Locknut has a set screw that tightens against the enclosure. Fifthly, selecting the right fitting is important. The choice between a bond bushing and a grounding Locknut depends on the specific application and the type of enclosure. Both fittings must be listed and labeled for grounding purposes. Sixthly, consider NEC requirements for grounding and bonding. The National Electrical Code provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure electrical safety and prevent fire hazard. Seventhly, NEC section 250.4 addresses grounding of equipment. This section requires that metal enclosures containing electrical conductors be grounded to provide a low impedance path for fault current. Eighthly, NEC section 250.92b addresses bonding of metal raceways and enclosures. This section requires that metal raceways and enclosures be bonded together to form a continuous electrical path. Ninthly, NEC section 250.96 addresses bonding of services. This section requires that the service equipment enclosure be bonded to the grounding electrode system. Tenthly, NEC section 314.4 covers metal boxes. Where a raceway or cable enters the box or fitting, it needs to be properly secured to it. The grounding continuity needs to be ensured by either bonding equipment to the box or using a fitting designed to reliably make the connection. 11thly, NEC section 250.148 covers continuity and connection of metal raceways and metal cables to equipment. Metal raceways and cables need to be joined to electrical equipment in a way that makes a reliable electrical connection. This ensures that the equipment grounding path is continuous. 12thly, specific to flexible metal conduit FMC and liquid-tight flexible metal conduit LFMC, additional considerations are necessary. These conduits are often used for connecting equipment that may require movement or vibration. 13thly, NEC section 348.60 covers grounding and bonding for FMC. For FMC systems, the code requires that an equipment grounding conductor be installed inside the conduit if the conduit is used to provide grounding. This is because FMC itself may not provide a reliable grounding path due to its construction. 14thly, NEC Section 350.60 covers grounding and bonding for LFMC. Similar to FMC, LFMC typically requires an equipment grounding conductor to be installed inside the conduit to ensure a reliable grounding path. 15thly, when using concentric knockouts, it is essential to address the potential for compromised grounding. Concentric knockouts can create gaps or discontinuities in a metal enclosure, which can interrupt the grounding path. 16thly, a bond bushing or grounding locknut helps to bridge these gaps and maintain a continuous grounding path. These fittings provide a secure mechanical and electrical connection between the conduit and the enclosure. 17thly, installation of a bond bushing or grounding locknut typically involves removing any paint or corrosion from the contact surfaces to ensure a good electrical connection. The fitting is then installed according to the manufacturer's instructions. 18thly, proper torque is essential when tightening the fitting to ensure a secure connection without damaging the enclosure or the fitting. 19thly, after installation, the grounding connection should be tested to verify its integrity. A low resistance ohmmeter can be used to measure the resistance between the conduit and the enclosure. 20thly, a low resistance reading indicates a good grounding connection, while a high resistance reading indicates a potential problem. 21stly, common grounding mistakes include using the wrong size of grounding conductor, failing to properly tighten grounding connections, and neglecting to install grounding bushings or locknuts when required. 22ndly, using the wrong size of grounding conductor can compromise the effectiveness of the grounding system. The size of the grounding conductor must be adequate to carry the maximum fault current that could occur in the circuit. 23rdly, failing to properly tighten grounding connections can result in a high resistance connection that can impede the flow of fault current. 24thly, neglecting to install grounding bushings or locknuts when required can create a potential shock hazard and violate electrical codes. 25thly, always consult the NEC and local electrical codes for specific requirements related to grounding and bonding. These codes provide detailed guidance on how to design and install safe and effective electrical systems. 26thly, proper grounding and bonding are essential for protecting people and property from electrical hazards. By following the NEC and best practices, you can ensure that your electrical systems are safe and reliable. 27thly, consider the specific application when selecting grounding and bonding methods. Different types of equipment and installations may require different grounding and bonding techniques. 28thly, for example, sensitive electronic equipment may require special grounding techniques to minimize noise and interference. 29thly, in corrosive environments, special grounding and bonding materials may be necessary to prevent corrosion and maintain the integrity of the grounding system. 30thly, remember that grounding and bonding are not just about meeting code requirements. They are also about providing a safe and reliable electrical system for the long term. 31stly, regular inspection and maintenance of grounding and bonding systems are essential to ensure their continued effectiveness. 32ndly, check grounding connections for corrosion or looseness and repair or replace any damaged components. 33rdly, by paying attention to grounding and bonding, you can help to prevent electrical accidents and ensure the safety of your electrical systems. 34thly, regarding the heat pump, ensure the disconnecting means is properly rated for the equipment. 35thly, this includes the voltage, amperage, and horsepower if applicable. 36thly, the disconnecting means should be readily accessible and located within sight of the heat pump or be capable of being locked in the open position. 37thly, properly sized conductors should be used for the heat pump, taking into account the ampacity and voltage drop requirements. 38thly, overcurrent protection devices, such as circuit breakers or fuses, must be properly sized to protect the conductors and equipment from overloads and short circuits. 39thly, when installing the heat pump, follow the manufacturer's instructions and all applicable codes and standards. 40thly, ensure that the heat pump is properly grounded to protect against electrical shock hazards. 41stly, consider using surge protection devices to protect the heat pump from voltage spikes and surges. 42ndly, ensure proper ventilation for the heat pump to prevent overheating and ensure efficient operation. 43rdly, regularly inspect the heat pump for any signs of damage or wear and tear, and address any issues promptly. 44thly, keep the area around the heat pump clear of debris and obstructions to ensure proper airflow. 45thly, schedule regular maintenance for the heat pump to ensure optimal performance and longevity. 46thly, when working with electrical systems, always follow safe work practices and use appropriate personal protective equipment. 47thly, if you are not qualified to perform electrical work, hire a licensed electrician to do the job. 48thly, when dealing with aluminum conductors, it is important to use connectors and fittings that are specifically designed for use with aluminum. 49thly, aluminum conductors expand and contract more than copper conductors, so it is important to use connectors that can accommodate this expansion and contraction. 50thly, using the wrong type of connector can lead to loose connections, overheating, and even fires. 51stly, when connecting aluminum conductors to copper conductors, it is important to use a connector that is specifically designed for this purpose. 52ndly, these connectors are typically made of a bimetallic material that prevents corrosion and ensures a reliable connection. 53rdly, when terminating aluminum conductors in electrical equipment, it is important to follow the manufacturer's instructions and use the proper torque. 54thly, over-tightening or under-tightening the connections can lead to problems. 55thly, aluminum conductors are more susceptible to oxidation than copper conductors, so it is important to clean the conductors and apply an antioxidant compound before making connections. 56thly, the antioxidant compound helps to prevent corrosion and ensures a good electrical connection. 57thly, when installing aluminum conductors, it is important to avoid sharp bends or kinks, which can damage the conductors and reduce their ampacity. 58thly, aluminum conductors are generally larger than copper conductors for the same ampacity, so it is important to ensure that there is enough space in the raceway or enclosure to accommodate the larger conductors. 59thly, when pulling aluminum conductors through a raceway, it is important to use a lubricant that is compatible with aluminum. 60thly, the lubricant helps to reduce friction and prevent damage to the conductors. 61stly, when splicing aluminum conductors, it is important to use a splicing method that is approved for use with aluminum. 62ndly, some splicing methods, such as wire nuts, are not suitable for use with aluminum conductors. 63rdly, when terminating aluminum conductors in a panel board or other electrical equipment, it is important to follow the manufacturer's instructions and use the proper torque. 64thly, over-tightening or under-tightening the connections can lead to problems. 65thly, when inspecting aluminum conductor installations, it is important to look for signs of corrosion, overheating, or loose connections. 66thly, any problems should be addressed promptly to prevent electrical hazards. 67thly, when working with aluminum conductors, it is important to be aware of the potential hazards and take precautions to prevent accidents. 68thly, always wear appropriate personal protective equipment such as gloves and eye protection when working with electrical conductors. 69thly, if you are not qualified to work with aluminum conductors, hire a licensed electrician to do the job. 70thly, always to energize the circuit before working on electrical equipment. 71stly, use a voltage tester to verify that the circuit is energized before touching any conductors. 72ndly, never work on live electrical equipment. 73rdly, always follow safe work practices and use common sense when working with electrical systems. 74thly, by following these guidelines, you can ensure that your aluminum conductor installations are safe and reliable. 75thly, NEC Table 310.15b16 provides ampacity ratings for conductors based on insulation type and temperature rating. 76thly, it is important to select conductors with an ampacity that is sufficient for the load they will be carrying. 77. Certain factors may need to be applied to the ampacity ratings in NEC Table 310.15b16 under certain conditions, such as when multiple conductors are installed in a raceway or when the ambient temperature is high. 78. Voltage drop can be a significant factor in electrical systems, especially over long distances. 79. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. 80. NEC Section 210.19 AM provides guidelines for limiting voltage drop in branch circuits. 81. NEC Section 215.2 AM provides guidelines for limiting voltage drop in feeders. 82. Grounding electrode conductors must be properly sized according to NEC Table 250.66. 83. The size of the grounding electrode conductor is based on the size of the service entrance conductors. 84. Bonding jumpers must be properly sized according to NEC Table 250.102. 85. The size of the bonding jumper is based on the size of the circuit conductors. 86. Equipment grounding conductors must be properly sized according to NEC Table 250.122. 87. The size of the equipment grounding conductor is based on the size of the overcurrent protection device. 88. Surge protection devices should be installed to protect sensitive electronic equipment from voltage spikes and surges. 89. Surge protection devices should be installed at the service entrance and at any other locations where sensitive equipment is located. 90. Ground fault circuit interrupters GFCIs should be installed in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. 91. Arc fault circuit interrupters of size should be installed to protect against arc faults, which can cause fires. 92. Smoke detectors should be installed in all sleeping areas and on every level of the home. 93. Carbon monoxide detectors should be installed near sleeping areas to protect against carbon monoxide poisoning. 94. Electrical panels should be properly labeled to identify the circuits. 95. Electrical panels should be kept clear of obstructions to allow for easy access in case of an emergency. 96. Electrical equipment should be regularly inspected for any signs of damage or wear and tear. 97. Any damaged or worn equipment should be repaired or replaced promptly. 98. Electrical work should only be performed by qualified individuals who are familiar with the NEC and local electrical codes. 99. Always follow safe work practices and use appropriate personal protective equipment when working with electrical systems. 100. Remember, safety is the most important consideration when working with electricity.